Our Earth has a long and dramatic history. Many powerful events have shaped our planet. Some of these events are well known, like the asteroid impact that wiped out the dinosaurs. But other events, equally transformative, remain lesser known to many. One such event was the Toba Supereruption. This colossal volcanic eruption happened in what is now Indonesia, on the island of Sumatra. It was an event of almost unimaginable scale, far exceeding anything modern humans have ever witnessed. The energy released was immense. The consequences were felt across the entire globe. Toba's story is one of incredible geological power and profound environmental change. The Toba eruption was so powerful it fundamentally altered the planet's climate for years. Some scientists believe it pushed early human populations to the very brink of extinction. Imagine a time when our ancestors faced a fight for survival unlike any other. The sky darkened, temperatures plummeted, and the world they knew changed in an instant. This is the dramatic and compelling story of Toba, a story of fire, ice, and the resilience of life. Understanding Toba is incredibly important. It tells us about the Earth's immense, sometimes terrifying power. The whispers of Toba still echo through time, carrying lessons we must heed. We often hear about volcanoes in the news. Mount St. Helens in the USA, Mount Vesuvius in Italy, these are familiar names associated with dramatic eruptions. But what exactly is a supervolcano? The name itself sounds incredibly dramatic, doesn't it? And it is for very good reason. A supervolcano signifies something far larger, far more powerful than the volcanoes we typically picture. It represents a geological force of a completely different order of magnitude, capable of planetary scale effects. A supervolcano isn't defined by its physical shape or its height above the surrounding landscape. Instead, the definition of a supervolcano is all about the volume of material it can erupt. Scientists use a scale called the Volcano Explosivity Index, or VEI, to classify eruptions. This scale runs from 0 to 8. Supereruptions are those that rank as VEI 8, the very highest category on this scale. These VEI 8 eruptions are thankfully incredibly rare events. They occur on timescales of tens of thousands or even hundreds of thousands of years. When they do happen, they can eject more than 1,000 cubic kilometers of volcanic material. So, where can we find the site of this ancient earth-changing cataclysm? The Toba Supervolcano is located on the island of Sumatra, which is part of Indonesia. This region is situated along the very active Sunda Arc. This arc is part of the larger Pacific Ring of Fire, a zone renowned for its frequent earthquakes and volcanic activity. Today, the evidence of Toba's incredible power is still strikingly visible, though perhaps not in the way you might expect. You won't find a towering, smoking mountain peak. Instead, the legacy of the Toba supereruption is a vast caldera. This enormous depression in the Earth's crust is now filled with water, forming what we know as Lake Toba. Lake Toba is, in fact, the largest volcanic lake in the entire world. It stretches approximately 100 kilometers in length and is about 30 kilometers across at its widest point. The sheer size of Lake Toba provides a profound, tangible clue to the magnitude of the eruption that created it. Let us try to journey back in time to approximately 74,000 years ago. This period was during the last ice age, a time when global climates were already cooler than today. Early modern humans, our direct ancestors, were already present on Earth. They had spread out from Africa and were beginning to populate parts of Asia. The Toba eruption, known as the youngest Toba Tuff eruption, was one of the largest explosive volcanic events in the last 25 million years of Earth's history. It is estimated to have ejected around 2,800 cubic kilometers of dense rock-equivalent material. Vast quantities of volcanic ash were blasted high into the atmosphere, reaching altitudes of 30 to 40 kilometers, well into the stratosphere. This ash then spread across enormous distances, carried by global wind patterns, from South Asia across the Indian Ocean to East Africa. The immediate effects in the vicinity of the eruption would have been unimaginably devastating. Pyroclastic flows, superheated, fast-moving currents of hot gas, ash and rock fragments would have surged across hundreds of kilometers of land. The volcanic winter induced by the Toba supereruption was incredibly severe. Scientific models and geological evidence suggest that global average temperatures may have dropped by as much as 3 to 5 degrees Celsius. This might not sound like a huge amount, but as a global average, it's a massive shift. In some mid to high latitude regions, the cooling could have been even more extreme, potentially reaching 10 to 15 degrees Celsius, creating conditions akin to a new sudden ice age. This abrupt and drastic climate change didn't just last for a few weeks or months. The cooling effects likely persisted for several years, possibly even a decade or more, with some longer-term impacts on climate patterns lasting even longer. Ecosystems across the entire globe would have been profoundly disrupted. Plants, the base of most food chains, would have struggled to photosynthesize due to the significantly reduced sunlight and the sustained colder temperatures. This in turn would have led to widespread starvation for animals dependent on those plants. What did this sudden, prolonged period of global cooling and environmental devastation mean for our ancient ancestors? Early humans at that time were living as hunter-gatherers. Their daily survival depended entirely on the health and productivity of their local environment, the availability of plants to gather and animals to hunt. A multi-year volcanic winter, with its drastically reduced sunlight, failing vegetation, and collapsing animal populations, would have been an existential catastrophe for them. This leads us to a fascinating and somewhat controversial idea known as the Toba catastrophe theory. Proposed by anthropologist Stanley Ambrose in the 1990s, this theory suggests that the Toba supereruption caused such a severe environmental crisis that it led to a dramatic reduction in the global human population. It posits that our species went through a genetic bottleneck. This term describes a situation where a species population is sharply reduced to a very small number of breeding individuals, severely limiting genetic diversity. Is there concrete evidence to support this dramatic idea of a human genetic bottleneck around 74,000 years ago? When we look at the genetics of our own species, Homo sapiens, we find something rather surprising. Human genetic diversity is remarkably low compared to that of many other primate species, including our closest living relatives, the chimpanzees. This limited diversity is often interpreted as a sign that our ancestors went through one or more periods of significantly reduced population size in the past. Some studies focusing on mitochondrial DNA, which is passed down exclusively from mothers to their offspring, point to a coalescence point. This is a theoretical point in time when all existing maternal lineages trace back to a single common ancestral female. Some genetic analyses have placed this coalescence point, or a significant reduction in lineages, roughly around the time of the Toba eruption. This has been used as supporting evidence for the Toba catastrophe theory, suggesting a link between the eruption and a human population crash. However, it's important to state that the Toba bottleneck theory is still a subject of active scientific debate. What about the Toba supervolcano today? Is it still an active threat, or has it become a dormant relic of a violent past? The Toba caldera system is in fact still geologically active. Magma continues to slowly accumulate in the chamber beneath the vast lake. This ongoing activity is evidenced by the gradual uplift of Samosir Island, the resurgent dome in the middle of Lake Toba, and by the presence of geothermal activity like hot springs around the caldera. However, the probability of another Toba-scale supereruption, a VEI-8 event occurring in the near future, say within our lifetimes or even the next few centuries, is considered to be extremely low. These colossal eruptions are incredibly rare phenomena, typically occurring on geological timescales, separated by hundreds of thousands or even millions of years. But it's crucial to remember that Toba is not the only supervolcano on our planet. There are other sleeping giants. Scientists around the world employ a sophisticated array of techniques to monitor supervolcanoes like Toba Yellowstone and Campi Flegrei. One key method involves measuring ground deformation. As magma moves or accumulates beneath the surface, it can cause the ground above to swell or subside. These subtle changes are tracked with high precision using GPS networks and satellite-based radar interferometry, which can detect centimeter-scale movements over vast areas. Another crucial aspect of monitoring is seismic activity. Scientists deploy networks of seismometers to listen for earthquakes. An increase in the frequency or intensity of small earthquakes or changes in their location can signal that magma is on the move deep underground. They also meticulously analyze the types of seismic waves generated, as these can provide clues about the processes occurring within the magma chamber and surrounding rock. This constant listening helps build a picture of the volcano's current state. The Toba Supereruption, which shook our planet some 74,000 years ago, stands as a profound and humbling reminder. It vividly illustrates the immense, almost incomprehensible power that resides within our Earth. Our planet is not a static, unchanging rock. It is a dynamic, evolving system capable of unleashing events that dwarf human experience and can reshape the very fabric of life on its surface. We are an integral part of this grand, restless system, not separate or immune from its powerful forces. Toba's story, particularly the theory of the human genetic bottleneck, highlights not only our species' potential vulnerability, but also our incredible resilience. If our ancestors did indeed face such an unimaginable environmental challenge, their survival against overwhelming odds is a testament to human adaptability, ingenuity, and perhaps the sheer will to endure. We carry the legacy of those survivors within our very genes. Their struggle is a deep part of our shared human story, a story of perseverance in the face of planetary upheaval.